Okay, check.
Sir, is it B?
Yes, it is correct. Great. What's the steps?
So I thought that um, the net force
Mm-hmm.
would be 900 minus 600,
Yes.
so 300. And if
300
the
is
weight
equal
of
to.
the person,
Mm-hmm.
300 is equal to ma.
Yes.
So
And
I
what's
took the weight of the person as 60.
mass, not the weight?
Mass, yes, yes, sorry, mass. And then if you divide that, you get A as 5.
Correct.
And then because we subtracted for the resultant force, that's why the acceleration would have to be upwards.
Good. That's the right logic. Should I explain?
Yeah. I mean, I got 5, but I didn't know if it was upwards or downwards.
Okay. So tell me the forces acting on this person. Uh,
Well, normal reaction force, mg downwards, and ma, which is the
mg, wait, mg is the weight, which is
yes,
equal to 600. And then you have the normal reaction, which
yeah,
is upwards. And the value for that is 900.
yeah.
That's it. These are the only two forces acting on it. Ma is not a force which you show on this. See,
Hmm.
according to the Newton's law, F net is equal to ma, right? So
Yes.
for net force, you just figure out what are the two forces are acting on the person. In this case, it's 900 and 600. So the
Right.
how much will be the net force?
300.
So 300 equals to ma. Now to find the mass, you use mg is equal to 600. So m will be 60,
Right.
isn't it? So put m as 60. So you get acceleration as 5, right? So
Okay.
the
So
magnitude is 5, but since you have a 900 going up, so that's why this entire elevator is actually going up,
hmm,
because the upward force is greater than the downward force.
downwards force.
That's why D.
Okay.
Makes
So
sense?
in so I have written a couple of formulas for tension
Mm-hmm.
when it comes to an elevator. So I've written when it goes upwards, usually you use mass into G plus A.
Wait, let's do that. Good thing you asked. So let's say we have an object M kept in an elevator, and the elevator is, let's say, going up. So the
Yes.
different forces acting on the block are mg and the, let's say, the normal reaction. So net force is equal to mass into acceleration. So you will write n minus mg is equal to ma. So n will be mg plus ma, right?
Right.
Which is equal to weight plus ma. So
Hmm.
this means n is the scale reading. So you can see the scale reading is always greater than the actual weight if the elevator is accelerating up.
Right. So, and if they ask for tension, it would be the same, right? Mg plus Ma.
One sec. If you are dealing with, see, okay, whenever we draw the free body diagram, you draw it for a single body. In this case, this is the free body diagram for small m. Right now, if you employ the same concept for the entire elevator itself, on the elevator, how many forces are acting?
Tension and the net force of NMMG, right?
We have tension acting upwards, and do not forget the weight of the elevator.
Right.
Elevator has also a weight of its own. So let's say it's capital Mg. Do we have any other force apart from these?
No, sir.
Think there is.
Sir, weight of the actual elevator means everything inside it, right?
Uh,
Or
no, 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 no. When we say elevator, it's only elevator, nothing else. So we are figuring out what are the forces acting on this elevator apart from tension and capital Mg. Capital M is the mass of the elevator.
then whatever's inside the elevator would also be acting downwards, right?
See, remember the Newton's third law, action and reaction. So where is the second N? See, one N is acting on small m. Where is the second N? Which completes the pair. Okay, Anishka, same question. Newton's third law, forces are equal and opposite. There should be a second N somewhere. Okay, Anishka, have any answer?
From the center of the elevator. Oh,
Okay, let's revise. Hang on.
wait,
Tell me. Yes, Anishka.
1 second. So the mg is Earth, the ground pulling the mass, right?
Okay. So the center of the Earth thing will be for mg's only,
Yeah.
but there should be a second N somewhere.
Oh, it should be downwards from the bottom of the elevator.
Yes, exactly. Good. So, watch it there. This is your second N.
Right. Yeah.
Because see, the small block is pushing the elevator down and the elevator is pushing the block up.
Up. Yeah.
Now you can apply the Newton's second law. So now, tell me what's the net force acting on the elevator?
Well, T will equal to mg plus n, right?
Upward force is T. You subtract all the
Subtract
downward force
mg minus mg plus n.
equals to capital M into A.
Yeah.
Right. So this is the equation for the elevator. But mostly they don't ask questions on elevator. They ask questions on whatever is inside.
Okay, sir.
Right. So just remember this rule. Scale reading is always greater than the weight if the elevator is accelerating up. And the reverse will happen. Scale reading is less than W if the acceleration is downwards. All right. So makes sense, both of you?
Yes, sir.
Let's move ahead. Next question. Next question is on projectile motion. Try this. Refer to this diagram.